In 1956, a group of scientists believed artificial intelligence could be solved in a single summer. 70 years later, we're still working on it. They were wrong. But not for the reason most people think. Over the next 12 minutes, you'll see the 5 eras that shaped modern AI. The dream, the 2 collapses almost nobody talks about, the quiet comeback, and the explosion we're living through today. By the end, you'll understand something most people miss. What we're seeing with AI right now didn't appear overnight. It's the result of 70 years of breakthroughs, setbacks, failures, and persistence. So let's start at the beginning. It's 1950. A British mathematician, Alan Turing, publishes a paper built around one deceptively simple question. Can machines think? Rather than answering directly, Turing proposes a test. If a machine can hold a conversation so convincingly that a person can't reliably tell it's a machine, then maybe the question of whether it truly thinks becomes less important. That idea became known as the Turing test. And even today, it still shapes how we talk about artificial intelligence. 6 years later, in the summer of 1956, a group of researchers gathers at Dartmouth College in the United States. The event is called the Dartmouth Summer Research Project. This moment is widely considered the birth of artificial intelligence as a field. It's also where the term artificial intelligence is formally introduced by computer scientist John McCarthy, and the researchers are incredibly optimistic. The proposal essentially argues that every aspect of learning and intelligence can be described precisely enough for a machine to simulate it. They believe a small group of scientists can make major progress in a single summer. Early results seem promising. Programs begin proving basic mathematical theorems. Others learn to play checkers. For a moment, it feels like the beginning of something unstoppable, but it isn't. And what happens next rarely makes it into the highlight reel. You're going to see the same pattern repeat throughout this story. Hype moves faster than reality. Expectations rise. Results disappoint. Funding disappears. And the field struggles to survive. The first time this happens is in the 1970s. During the 1960s, governments invested heavily in AI research. They expected machine translation, human-like reasoning, and powerful problem-solving systems. Instead, researchers produced programs that worked only in narrow, carefully controlled situations. The moment they encountered real-world complexity, they failed. Then came a major turning point. In 1973, a British government review, as the Lighthill report concluded, that AI research had fallen far short of its promises. Funding in the United Kingdom was cut dramatically. In the United States, DARPA, one of the largest supporters of AI research, also reduced its investment. The result was what became known as the first AI winter. Research slowed. Labs closed. And some scientists stopped using the term artificial intelligence altogether because it had become difficult to secure funding. The dream survived, but for nearly a decade, it lived mostly in the shadows. The 1980s bring a comeback, but this time, the goal is more practical. Instead of building general intelligence, researchers focus on expert systems. These programs rely on thousands of handwritten rules created by human specialists. If this condition happens, do that. If another condition appears, do something else. Expert systems are used in medicine, finance, and business decision-making. For the first time, AI becomes a real commercial industry. Companies invest heavily. The market grows quickly. And then the same problem appears again. The systems are difficult to maintain. Every new situation requires more human-written rules. Costs rise. Complexity explodes. And eventually, the market collapses. This becomes the second AI winter. But during this period, one event captures global attention. In 1997, IBM's Deep Blue defeats world chess champion Garry Kasparov. For many people, it feels like a historic moment. A machine has beaten the best human player. in the world at a game associated with intelligence and strategy, but there's an important detail that often gets overlooked. Deep Blue could play chess, and only chess. It couldn't hold a conversation. It couldn't recognize faces. It couldn't identify a cat in a photograph. It was extraordinarily powerful in one specific area and completely incapable outside it. That limitation becomes the challenge the next generation of AI researchers finally begins to solve. This may be the most important era in the entire story, and it's the one many people skip over. Three major developments quietly come together. First, the internet creates enormous amounts of data. Second, graphics processing units, or GPUs, originally designed for video games, turn out to be exceptionally good at AI calculations. Third, researchers continue improving an older idea known as neural networks, which are loosely inspired by the connections between neurons in the human brain. 4 years. Progress is steady, but largely unnoticed. Then comes a breakthrough. In 2012, a neural network-based system dominates the ImageNet competition, outperforming competing image recognition methods by a huge margin. Many historians point to this moment as the beginning of the deep learning era. The entire field starts moving in a new direction. Then, in 2016, another milestone arrives. Google DeepMind's AlphaGo defeats world champion Lee Sedol, the game of Go. This achievement matters even more than Deep Blue. Why? Because Go is vastly more complex than chess. The number of possible positions is so large that brute force calculation alone isn't practical. To succeed, AlphaGo has to develop something that looks remarkably similar to intuition. There are no dramatic headlines about AI collapsing this time. No winter. No disappearance. Just steady progress, year after year, while most of the public isn't paying attention. Then comes 2017. A team of researchers at Google publishes a paper with an unusual title. Attention is all you need. The paper introduces a new architecture called a transformer. If you remember only one technical term from this video, remember that transformers become the foundation for nearly every major AI breakthrough that follows. Large language models, GPT systems, and many modern image generation tools. From this point forward, progress accelerates dramatically. Each generation of AI becomes larger, faster, and more capable. Then comes November 2022. ChatGPT is to the public. Within days, it becomes the fastest growing consumer application in history. Suddenly, the technology that began as a research proposal in 1956 is being used by students, professionals, parents, and grandparents around the world. And the pace isn't slowing down. Modern AI systems can work with text, images, audio, and video. Some can take actions instead of simply answering questions. Every few months, a new breakthrough arrives that would have felt like a decade of progress back in the 1980s. Now, here's the point we started with. Artificial intelligence has already survived to near-death experiences twice. Expectations raced far ahead of reality twice. Funding collapsed, and twice, the field nearly disappeared. What's different today isn't the hype. If anything, the hype may be louder than ever. What's different is that the technology finally caught up. The data existed, the computing power existed, and the underlying architectures finally worked. That doesn't mean every prediction will come true, and it doesn't mean every concern is unfounded. Whether this future should be celebrated, regulated, feared, embraced, or some combination of all four. That single quotes S. The debate happening right now. In real time, and it's far from settled. If you want to explore what comes next, artificial general intelligence, the future of jobs. Regulation. Automation. And where all of this may be heading, that's the next video. And it's the one I think matters most. Subscribe so you don't miss it, and I'll see you in the next one.